In this session we will learn about data structures in Scilab. Data structures are used to store and organize data in a systematic way. For this, Scilab has three types of data structures: cell array, list, and struct. We will see each in detail. Cell arrays are able to store variables of different size or type. It uses braces as indexing operators. Commands listed in the table are used to create and operate on cell arrays. Let's see these commands in more details. To create a cell array, we use the command cell. We specify the size of the cell array in the cell command, and initially get an empty array. In the output, we can see the size and pattern of the cell array with empty cells. We can place any variable of any size in this cell array. Now we add some data to the cell array. First we define two variables b and c. Variable b is an array of numbers. Variable c is an array of string variables. We now assign these variables to the cells of cell array A by using curly braces operator. In the output, we can see that the variables are placed in the cell array. We can access the variables of the cell array using curly braces operator. Here variable d is assigned the array of numbers from the cell array A. We can also use makeCell command to create the cell array. MakeCell creates a cell array of dimensions given by dim's keyword and with the given input arguments. It requires the size of all the variables to be known before creating the array, whereas cell command can create an empty cell array. IsCell command is used to check if the variable is a cell array object. CellStr function is used to create cell array with all entries of strings. Here we learned that cell arrays store wide range of data variables compactly in a single variable, and can be used to create object-oriented programs and develop modular codes. Now we consider the next data structure, list. A list is a collection of data objects. They can be scalars, matrices, character strings, string matrices, functions, as well as other lists. Let's define a list variable A. To create the list, we insert variables as arguments in the list function. The arguments of the list function are arbitrary Scilab objects. In the output we can see the contents of the list. To extract an element from the list, we use brackets with index of the element. We can also use colon operator to extract all elements of the list and assign it to other variables. To change the variable at any position, we assign a new variable at that position. We can append a new variable at the end of the list using $operator. We can get the number of elements in the list using length command. We can also combine two or more list objects into a single object using listcat command. Here we learned that list data structure can store variety of Scilab objects and can be very useful in complex programs to handle data. Now we consider the next data structure, struct. A struct is a collection of data objects very much like structures in other programming languages. The data of the structure is accessed using an object which represents that structure. Struct is defined by providing field name and value pair for each field variable that we want to store in the structure. Let's define a struct object A. To create the struct, we specify field name and value for the variables in the struct function. In the output we can see the contents of the struct. To extract data field from the struct object, we use dot operator and name of the field. We can get all field names in a struct using field names command. Let's see a practical example. Here we define some variables. L and H are length and width of the rectangular plate. Nx and Ny are number of nodes in x and y direction. Now, we create a mesh data structure to store all the variables. We can then pass the struct object to any function as argument and use the data stored in the structure. We see that by using any data structure, we can store and manage data variables in a simplified manner. We can also pass these data structure variables as arguments to other functions and create complex object-oriented modular programs. That brings us to the end of this session. Thank you for your interest and attention.